Hey everybody, today we are going to test out different types of models that we can do using our graphing calculator. Yesterday we talked about the first one, which was how to find a linear model. We're going to use this a lot of the time. Now we have all of these different other options. You're not going to see these two a whole heck of a lot, so I would really just focus on the new ones right there. And to be honest, we're going to learn about how you can very easily know which choice is the best anyway. So don't get overwhelmed by all the different types of models. Let's just go into our data, type it in, and I'll show you some tricks. Okay. So we are going to hit the Stat button. Okay, that's the first thing we're going to do is hit the Stat button. And we're going to go to Edit, and you should have some lists. If there is something in your list already, then scroll up to where it says L1, L2, whatever it is, and hit Clear, and that will get rid of every single last thing in the list. Okay. Now, we are testing out unemployment claims over here for Volusia County, Florida. Whenever you're dealing with years, okay? Whenever you are dealing with years, you do not want to type in things like 1992, 1993. That's going to be really, really awful. So what we should do instead, just to make it easy, just take 1990 and call that 0. So if we say that 1990 is year 0, what that does for us is that allows us to, instead of type in 1992, we can just type in 2. Okay, so that's kind of the fastest way to go about doing this. It also gives you the best data because we don't have to worry about huge numbers. Okay, so that's what we're going to go with. Let's make that happen. Be sure as you are typing in these values that you're being very careful to make them line up. I've had a lot of people that are getting dimension mismatches as their error code, and that's because you have more x values than you have y values. So if that's the case, you're going to have to redo it, and you're going to have to check all of your data, and I'm sure that's going to thrill you to death. All right, now I'm going to go into the window here. If you look on your paper, you have been essentially given a graph of what's going on here. It starts high, then we have a time where there are not a whole lot of unemployment claims, and then it goes back up high again. That is definitely not linear. Okay, that's why in this particular example, it is suggested that you use a quadratic. So let's talk about how to do that. First of all, hit the window button, because if 1990 is year 0, and 2005 is year 15, then we should have our window go from 0 to 15. Or you could even do 0 to 20 if you want. It doesn't really matter. I'm going to have my tick marks go by 2s. You could also do 5. If you wanted to, you could also do 5 because, no, there you go. I did not want that. Okay. Yeah, they did 5 down there, so we could even do that. The claims sort of bounced around between 500 and 2,000. I'm going based off what we have down here. Okay, so let's make that happen. And if we check, we need to double check and make sure that our stat plot is on. And what do you know? That's our data. The data is not great. Okay, but that's okay. We're going to go with it anyway, and we are going to try to create a quadratic model because it started high, went down, and then went back high again. All right, so what we're going to do, we're going to have the calculator do all the dirty work for us. We're going to go in where it says Stat again, but this time we are going to go to Calc. Yesterday we were doing a whole lot of linear regressions. Today, because it started up high and went down and back up again, we're going to make it a quadratic. Okay, so we're going to hit Quadratic Regression, and it's going to give us that data. If you're wondering where that came from here, I had it do it on the calculator. You can verify it on your note sheet right there. Now, I have a problem here. The r squared value was not very good. Now, yesterday, some of my classes talked about it. Some of them didn't get to it. We want that number to be very close to 1. If that number is not very close to 1, then that means it was not a very good approximation. Now, there were a lot of requests yesterday to have me show you one more thing before we move on to the next example. People wanted to know, okay, so we have our graph right here. How can I actually graph that without having to type it in? Because we don't want to do 14.3826 x squared. Like, that's going to be a pain. The shortcut for that is if you go to vars, we're going to be using variables here, but we're going to find a little shortcut in here. If you go to vars, we can actually take the statistics that we just found, which was number 5, and we can use those statistics inside the calculator to find the equation that we just created, which is a super smooth move because now you can literally just take all that data, throw it in, and then the calculator will graph it for you, which is super amazing, saves us a ton of time. Okay. Now, if we are moving really, really fast, if it seems like we're moving really, really fast, that's okay, because you can always pause the video as we go. All right, let's go back in and we'll do example number 2. We're going to get to 4 examples today. Okay, I'm going to clear out my lists. And once again, we're dealing with years. So what I'm going to do is I'm going to take 1900 and I'm going to call it 0. That way, instead of having to type in all of this stuff, I can just be consistent. Now, that means 2000 would be year 100 because that would be 100 years later, and 2005 would be year 105. Now, what we're looking at is what percent of the American population was foreign born. Now, this is actually really interesting data here because what happens, you can see right around World War II, the number drops down quite a bit because in World War II, we were being very protective of our borders, obviously, as that kind of comes and goes if you look at numbers in society. So we had a very high foreign-born population, then it dipped down, and now it's coming back again. So you take a look at the data. Let's see what's going on. This one, we're going to have to change our window again. Now, we went from year 0, which was 1900, all the way to 2005. So I'm going to have to go maybe to 110. I'll go by tens. And then it's percentages. It dipped as low as 4.7%. It went as high as 14.7%. So I'm going to go 15. I'm just going to go, let's look and see on this paper. They went by 2s. So I think we should probably go by 2s as well. Okay. And their scale actually went by 20 as far as years were concerned. Let's see. Ooh, wow, there you go. Now, it is suggested, according to the data, that you do a cubic regression. So we're going to go into the menu that we normally do, Stat, Calc, and this time I'm going to do a cubic. That's x cubed, but it doesn't really matter how well you know these, as long as you know that quadratic dips down and back up. Linear should make a straight line, and we're going to do another example later that's going to be something different that I want to make sure you pay super close attention to. All right, so we're going to do a cubic regression equation. That took the calculator a little while, but that's very, very normal because a cubic regression equation is going to be really complicated. But once again, it doesn't even matter. It doesn't matter how complicated it is because I can go into y equals, I want to clear out the old one, and I can just have the calculator import it for me. I'm going to hit VARS, VARS. Shout out to all the students who told me that if you want to square something, you to it. So I guess we're just going to speak that language. We're going to go to VARS, all right, then go to statistics, and I want to steal the equation that we just came up with. Whoa, that's crazy. Check that out. Look at this model, though. They nailed it. It looks perfect. That's amazing. You can tell. The r squared value was really high on this one, which means it was a very good fit. The closer it is to 1, the better the model was. All right, so again, if we are moving too fast, that's okay. Pause the video, make it happen, that's okay. Just make sure you get these 4 done. We're going to use that same year concept for the next example, and we're going to talk about minimum wage. Now, I do think this one is super funny because the last piece of data, we're going to ignore the 19s, okay? We're just going to go right into the other numbers. That last piece of data I love because my very first job, that was my pay. So maybe that just strikes a chord with me. Now they gave us 20 x values and they gave us 20 y values. Now this was not average pay, this was minimum wage. So if you were like me and you were just bagging groceries, that was what you would get. We're going to go from 0 to 100 years again. We're going to go by tens. We're going to start at $0 per hour and we're going to work up to $6 an hour. And if we graph, okay, there you go. Starts low, goes up. And they gave 3 different examples. Okay, so basically the reason we wanted to go over this set of data was because you could actually try out 3 different models. Now, I don't want you to worry about anything except for that r squared number. Okay, the linear model had a 0.92. Go back here, let's make a new one. The quadratic model had an r squared value of 0.987. And the exponential model, if you go back here and you do one more, the exponential model, that's all the way down, exponential. That one is taking the calculator a minute. That one had an r squared value of 0.971. So notice the quadratic was best. Okay, we're going to practice that a whole lot in the next lesson, so pay attention later. All right, the very last thing I want you to go over. Okay, we're going to do one last set of stats. This is going to go super fast. Okay. And this time we're going to keep it short and sweet. We are doing the population of foxes. Now, I don't know if you remember this. I really hope you do. In the beginning of the semester, we did exponential growth. And what you discover, population, if it is not being controlled, is usually exponential. So that's why it is suggested to us that we do something exponential on this. So I'm going to go to stat, okay, and I'm going to make an exponential model of the data. Okay. So the model says 61.59. And then it's a times b to the x, that's what's going on. B is 1.1207. Sorry, you keep getting my other screen here. To the x power. The reason this is a great model, check out that r squared number, it's 0.9868. So we're going to use it, we're going to go with it, we're going to go to y equals, and we're going to take that model and we're going to throw it in. So we're going to go to vars, statistics, equation, and regression. Okay. Now my window here, because we're just talking about the fox population over time, it doesn't need to be perfect, but it did go from 0 to 500 foxes. So let's do that. There you go. And check out that model. That model is absolutely perfect. So the very last thing that we want to do now is we want to answer the question, what will the population be in year 20? So we have year 18 was 475. What is it going to be after 20 years? So we are going to go into our table. We have some little details here. I don't really want these, so I'm just going to hit delete, delete, delete. By the way, if your table does not look like this, then you're going to want to go to table set. Make sure you have ask first and then auto. Then you go to table. I want to know what it's going to be after 20 years, so I'm going to type in 20, and their prediction is 602 boxes. Okay, so we have all sorts of different models, all sorts of different stuff we're dealing with here. Make sure you watch this, you go step by step, and you do all four. If you want to make a sketch of the fox thing last right here, that's probably the last thing you need to do. We'll go from 0 to 500, and that bell means it's my time to let you go. So, I hope this helps you out. Hope you watch it a couple times through, do what you need to do, and I'll talk to you all next time.